Friends, thank you for being here today. What if I told you that while the world watches SpaceX launches and Chinese space stations, they're completely missing the country that has quietly become the indispensable backbone of every space mission on Earth? And what happens when everyone realizes that the International Space Station, satellite communications, and space exploration itself can't function without the technology, robotics, and infrastructure controlled by one nation that most people think just makes maple syrup? Most people don't know that Canada has become the silent emperor of outer space. Every space mission depends on Canadian robotics. Our satellites provide the most advanced Earth observation capabilities on the planet. We control optimal geographic positions for polar orbit launches that are essential for global satellite coverage. But here's what should reshape how we think about space power. We don't just participate in space exploration, we make it possible for everyone else. This isn't just about launching rockets or building space stations. We're talking about controlling the robotic systems that assemble space infrastructure, the surveillance satellites that monitor global activities, and the ground stations that coordinate international space operations. But here's the question that will define space geopolitics. What happens when space exploration depends on Canadian technology and we control the off switch? This is the story of how engineering excellence, strategic positioning, and technological innovation are making Canada the invisible empire of space operations, and why the next space breakthrough might depend more on Canadian robotics than American rockets or Chinese ambitions. Before we examine Canada's space dominance, we need to understand how dramatically space activities have become essential to modern civilization, and why controlling space infrastructure has become the ultimate strategic advantage. The numbers reveal the staggering importance of space-based systems to modern life. The global space economy is worth over $400 billion annually and growing at 8 to 10% per year. Over 4,000 active satellites orbit Earth, providing communications, navigation, weather monitoring, and intelligence services that modern society depends on completely. GPS satellite navigation systems guide everything from smartphone maps to precision agriculture to military operations. A disruption to GPS services would cripple transportation systems, financial networks, and emergency services within hours. The economic impact of GPS services to the U.S. economy alone is estimated at over $1.4 trillion annually. Communication satellites carry over 60% of international telephone traffic and provide internet connectivity to remote regions worldwide. Satellite internet services like Starlink are becoming essential infrastructure for global communications, especially in regions without terrestrial internet infrastructure. Earth observation satellites monitor climate change, track natural disasters, provide agricultural intelligence, and conduct surveillance operations that affect national security and international relations. The data from these satellites influences everything from weather forecasts to military planning to environmental policy. Space-based manufacturing and research are becoming increasingly important for developing new materials, pharmaceuticals, and technologies that cannot be created under Earth's gravity conditions. The International Space Station conducts experiments that contribute to medical research, materials science, and industrial applications worth billions of dollars. Asteroid mining and space resource extraction represent emerging industries that could be worth trillions of dollars. Near-Earth asteroids contain precious metals, rare earth elements, and water that could revolutionize resource availability and economic relationships on Earth. Space debris, monitoring, and removal are becoming critical services as space becomes more crowded. Over 34,000 pieces of trackable space debris larger than 10 centimeters orbit Earth, posing collision risks to active satellites and space stations. The Kessler syndrome effect, where collisions create more debris that causes more collisions, could potentially make certain orbital zones unusable. The most significant development is the militarization of space, with major powers developing anti-satellite weapons, space-based surveillance systems, and defensive capabilities that could reshape international security relationships. This space infrastructure revolution is creating new forms of technological dependence and strategic leverage. Countries that control critical space technologies gain enormous influence over global space operations and the terrestrial systems that depend on space-based services. Now let's examine what Canada actually controls in terms of space infrastructure and technology. Our advantages go far beyond just having a space agency. We possess integrated space capabilities that make us indispensable to virtually every major space operation. Let's start with the Canadarm, which represents perhaps the most successful and influential space technology ever developed. The Canadarm robotic manipulator system has been essential to space operations for over 4 decades, and its successors continue to be the backbone of space construction and maintenance activities. The original Canadarm flew on over 90 space shuttle missions, deploying satellites, conducting repairs, and assembling the International Space Station. Without the Canadarm, the ISS could not have been constructed. The precision and reliability of Canadian robotic systems made complex space construction possible for the first time. Canadarm2 on the International Space Station continues this legacy, serving as the primary robotic system for station operations. It captures visiting spacecraft, moves equipment and supplies, assists with spacewalks, and maintains the station's exterior. The ISS simply cannot function without Canadian robotic systems. The Mobile Remote Servicer System, Canadarm3, is being developed for NASA's Lunar Gateway Station, ensuring that Canadian robotics will be essential for humanity's return to the Moon and eventual missions to Mars. This positions Canada as an indispensable partner in all future deep space exploration. But robotics represents just one dimension of Canadian space dominance. Our satellite capabilities provide some of the world's most advanced space-based services and monitoring systems. The RadarSat constellation represents the most sophisticated Earth observation satellite system ever deployed. RadarSat. Satellites use synthetic aperture radar to monitor Earth's surface through clouds and darkness, providing continuous surveillance capabilities that optical satellites cannot match. RadarSat data is used for disaster monitoring, ice monitoring, oil spill detection, ship tracking, and agricultural monitoring worldwide. During natural disasters, RadarSat provides essential information for emergency response and recovery operations. The system's all-weather day-night capabilities make it irreplaceable for critical monitoring applications. Our Arctic surveillance capabilities demonstrate how Canadian satellites provide strategic intelligence that other nations cannot obtain independently. RadarSat monitors Arctic ice conditions, shipping traffic, and territorial activities that are essential for Arctic sovereignty and environmental monitoring. Maritime domain awareness represents another area where Canadian satellites provide globally essential services. Our satellite systems track ship movements, monitor fishing activities, detect illegal maritime activities, and provide navigation safety information across the world's oceans. The ground infrastructure supporting Canadian space operations provides another layer of strategic control. Canadian ground stations coordinate satellite communications, process satellite data, and provide tracking services for international space missions. Our geographic position provides unique advantages for polar orbit satellite operations. Polar orbits are essential for Earth observation, weather monitoring, and global communication satellites that need to provide worldwide coverage. Canada's northern latitude provides optimal access to polar orbital insertion trajectories. To understand how this translates into global leverage, we need to look at how international space operations depend on Canadian technologies, and how this dependence creates strategic influence opportunities. The International Space Station demonstrates the clearest example of how Canadian technology creates strategic dependence. The ISS is a $150 billion international project involving space agencies from the United States, Russia, Europe, Japan, and Canada. Yet the station cannot function without Canadian robotic systems. Canadarm2 performs essential functions that no other system can replicate. It captures visiting cargo vehicles, provides precise manipulation capabilities for maintenance operations, and serves as a mobile platform for astronauts conducting spacewalks. If Canadian robotic systems failed, the ISS would face operational crisis within weeks. This technological dependence gives Canada influence over ISS operations and international space policy that far exceeds what our financial contribution would suggest. Canadian astronauts receive ISS crew slots proportional to our technological contribution rather than our financial investment. The dependency extends to future space missions. NASA's Artemis program to return to the Moon relies on Canadian robotics for the Lunar Gateway Station. Without Canadian participation, the program would need to develop alternative robotic systems that would cost billions of dollars and take years to develop. Commercial space operations increasingly depend on Canadian ground infrastructure and satellite services. SpaceX, Blue Origin, and other private space companies use Canadian ground stations for satellite tracking and communication services. Canadian RadarSat data is essential for launch, site monitoring, and space debris tracking. Satellite constellation operators like Starlink depend on Canadian ground infrastructure for polar orbit operations and Arctic coverage. Without Canadian ground stations, many satellite services would have significant coverage gaps in northern regions. International space security operations depend heavily on Canadian satellite capabilities. Our RadarSat systems provide surveillance information that is shared with allied nations for space situational awareness and security monitoring. This intelligence sharing creates diplomatic relationships and strategic partnerships. Climate monitoring and environmental research depend extensively on Canadian satellite data. RadarSat ice monitoring is essential for understanding Arctic climate change. Canadian atmospheric monitoring satellites provide data that is crucial for global climate research and policy development. The European Space Agency, Japanese Space Agency, and other international partners depend on Canadian expertise for robotic systems development. Technology transfer agreements and joint development programs position Canadian companies as essential partners for international space projects. I want to pause here because this raises a fascinating strategic question that I'd love to hear your thoughts on. As space becomes more militarized and competitive, Should Canada leverage our technological advantages to maximize our influence in space operations? Or should we maintain our current approach of international cooperation and technology sharing? This choice could define Canada's role in space for decades and affect everything from our access to space missions to our influence over space governance. What's your perspective on Canada's space strategy? Share your thoughts in the comments below. Beyond current space operations, Canada is positioning itself to dominate emerging space technologies and industries that could reshape the space economy for decades to come. Asteroid mining represents one of the most promising frontiers for Canadian space leadership. Canadian mining companies have world-class expertise in resource extraction, processing, and logistics that translates directly to space mining operations. Our experience with remote, harsh environment mining provides unique advantages for asteroid resource extraction. Near-Earth asteroids contain platinum, gold, rare earth elements, and water that could be worth trillions of dollars. A single metallic asteroid could contain more platinum than has ever been mined on Earth. The technical challenges of asteroid mining align closely with Canadian expertise in robotics, remote operations, and resource processing. Canadian companies are already developing technologies for space mining operations. Planetary Resources, before its acquisition, had significant Canadian involvement. Current Canadian companies are developing robotic systems, processing technologies, and mission planning capabilities for asteroid mining missions. Space manufacturing represents another frontier where Canadian expertise provides competitive advantages. Microgravity environments enable manufacturing processes that are impossible on Earth, potentially producing superior alloys, crystals, and pharmaceutical products. Canadian robotics expertise is essential for space manufacturing operations that require precise manipulation in zero-gravity environments. Our experience with remote-controlled industrial operations provides foundation knowledge for automated space manufacturing systems. The space debris removal industry is creating opportunities for Canadian companies to leverage our robotics expertise for commercial space services. Space debris poses increasing risks to active satellites and space operations, creating demand for removal and mitigation services. Canadian robotic systems are ideally suited for space debris capture and removal operations. The precision and reliability demonstrated by Canadarm systems make Canadian robotics the preferred solution for delicate space debris removal missions. Satellite servicing represents a growing industry where Canadian robotics provide unique capabilities. Instead of allowing satellites to fail when they run out of fuel or suffer component failures, robotic servicing missions can extend satellite lifespans and upgrade capabilities. Canadian companies are developing satellite servicing capabilities that could revolutionize how satellites are maintained and operated. These services could extend satellite lifespans from 15 years to 30+ years, while reducing the need for new satellite launches. Space-based solar power represents a potential future industry, where Canadian expertise in both space operations and renewable energy could provide competitive advantages. Large-scale space solar installations would require extensive robotic assembly and maintenance capabilities. However, maintaining and expanding Canada as a space leadership requires strategic investments and policy decisions that many Canadians don't fully appreciate. Space technology development requires sustained investment over decades. Unlike terrestrial technologies, space systems must operate in extreme environments without possibility of repair or maintenance. This requires extensive testing, qualification, and reliability engineering that demands patient capital investment. The Canadian Space Agency needs continued funding to maintain our technological leadership and international partnerships. Space technology development cycles are measured in decades, requiring consistent long-term investment that can survive political changes and budget pressures. International partnerships are essential for Canadian space leadership because space projects increasingly require collaboration between multiple countries and organizations. Canada's reputation for reliable partnership makes us valuable collaborators, but we need diplomatic and trade policies that protect our technological advantages. Skilled workforce development is critical for maintaining Canadian space expertise. Aerospace engineering, robotics, satellite technology, and space operations all require specialized skills that take years to develop. Canada needs educational programs and immigration policies that can supply the skilled professionals needed for expanding space industries. Commercial space industry development requires supportive regulatory frameworks and investment incentives. Canadian space companies compete with heavily subsidized international competitors, requiring government support and policy frameworks that encourage private space industry growth. Space security and defense capabilities are becoming increasingly important as space becomes more contested. Canada needs space-based surveillance, communication, and potentially defensive capabilities that protect our space assets and support our international partnerships. If you're finding this analysis of Canada's space transformation valuable, please take a moment to like this video and subscribe to the channel. It helps us continue producing in-depth analysis of the technological and strategic trends that are reshaping our future. The space economy represents one of the fastest growing and most strategically important sectors of the global economy. Countries that achieve leadership in space technology will influence everything from global communications to resource extraction to international security for decades to come. Canada possesses space capabilities that are impossible for other countries to replicate quickly. Our robotics expertise has been developed over 4 decades of space operations. Our satellite technologies provide unique capabilities that serve global markets. Our geographic position provides optimal access to essential orbital trajectories. But possessing these space advantages is not the same as leveraging them strategically. Canada needs to make conscious decisions about how to use our space leadership while maintaining the international partnerships and technological advantages that make our space success possible. The next decade will be critical for establishing our role in the expanding space economy. The investments in space technology, international partnerships, and industry development we make now will determine whether Canada becomes a major space power or simply provides supporting technologies for other countries' space ambitions. The choices we make will affect not just our space capabilities, but our technological competitiveness and international influence as space-based systems become more important for terrestrial economic and security systems. Friends, we are living through the transformation of space from a scientific frontier to an essential economic and strategic domain. While the world's attention focuses on rocket launches and space races, the real power lies in the technologies and infrastructure that make space operations possible. Canada has quietly become the indispensable nation of space operations. Our robots assemble space stations that other countries finance. Our satellites provide surveillance and monitoring services that global partners depend on. Our ground infrastructure coordinates space missions that wouldn't be possible without Canadian participation. The question isn't whether Canada can become a major space power. We already are, through our unique combination of essential technologies and strategic capabilities. The question is whether we'll have the vision and commitment to leverage our space advantages strategically while maintaining the partnerships and cooperation that make space exploration possible. The rockets are launching. The satellites are orbiting. The future of space exploration is being built by robotic systems that bear the Canadian flag. Canada has the technology to make space missions possible, the expertise to lead space innovation, and the opportunity to shape how humanity explores and utilizes space. What we do with this space opportunity will determine not just our role in space exploration, but our influence in a world where space-based systems increasingly determine terrestrial power and prosperity. The space revolution is here, and it runs on Canadian robotics, Canadian satellites, and Canadian expertise. Canada can either embrace our role as the silent emperor of space, or watch others build their space futures with our technology and our cooperation. Thank you for joining me for this exploration of Canada's space empire. What aspects of our space dominance do you think offer the most strategic potential? Should we focus on robotic systems, satellite capabilities, or emerging industries like asteroid mining? Share your insights below, and I'll see you in the next analysis of the forces shaping our cosmic future.